Hello, I'm Greg. This video demonstrates how to create an aquarium, air pump, and timer using a BBC micropit. The parts needed for this project are listed in the description. To begin, open Mu MicroPython editor and select BBC microbit mode. Import the microbit module. First, let's create a fish class with the fish's name. Then we'll create a timer class and set the on and off time for the pump. The time is in milliseconds. Initialize a variable called nextUpdate to 0. This will be used to turn the pump on and off. Define a function called setNextUpdate that receives two time parameters and sets the nextUpdate variable to the sum of these parameters. Define another function called getNextUpdate that returns the nextUpdate instance variable. Create a pump class and initialize a variable called powerOn to false. A function is created called displayPowerStatus that displays the power on status on the microbit LED grid. Two more functions are created called on and off. These functions will write a digital value of 1 or 0 respectively. Write to the pin that is connected to the base of the transistor. Pin 1 is used in this example. Declare a pump and timer object to none. The main program is executed in a while true loop. Inside this loop, let's assign the objects to the correct class if they are assigned to the none type. A running time begins when the microbit is powered on. Running time is used to create a non-blocking microbit timer. The microbit buttons and functions are not blocked and still available for use. If the running time is greater than the next update time, switch the pump on or off. Then reset the next update time using the current running time and the assigned pump time. Display the power status on the LED grid. Let's add an accelerometer feature that displays the fish's name when we shake the microbit. Now we'll add a manual override for the pump power. If button A is pressed, the pump will turn on. If button B is pressed, the pump turns off. The update time will not be affected by pressing A or B. Attach a wire to the microbit pin 1 as well as the 3-volt and ground pin. Connect pin 1 to one of the positive rails on the breadboard. Add a jumper wire from the positive rail to the node of a terminal. A 1 Watt Zener diode is connected with the direction of current flowing away from pin 1. The base of the transistor is attached to the diode terminal. Attach a wire from the microbit 3-volt pin to the other positive rail. Connect the positive end of the pump to this positive rail. Add a jumper wire from the emitter of the transistor to a terminal. Then add a jumper from the collector of the transistor to a terminal. Attach a wire from the microbit ground pin to the emitter terminal. Connect the negative end of the pump to the collector. Power on the microbit. The microbit will turn on the pump and begin the timer. Press button A to manually start the pump. Button B will stop the pump. The wiring can also be soldered together to avoid using a breadboard. Thank you for watching.